It is difficult to clearly distinguish features based on the earlier definitions. Therefore, the researchers propose a more relaxed creation, definition 3. Equation 2 suggests using mutual information. To measure the independence of subspaces. Strictly speaking, for the subspaces to be independent, this value should be 0, but they relax this condition to accept values close to 0. Equation 3 measures how easily separable or how mixed. If it finds V and C, which are linear transformations of the multidimensional features F. So that the transformed value is close to a small threshold epsilon. Then it measures the frequency of the linear transformation values, the vector value. If the distribution of this value is small, it indicates that the subspaces are highly mixed. As you can see here, this is very highly mixed. This distribution is not that small. It seems to be not that mixed. At this point, I believe a flaw in the paper become apparent. While relaxing the criteria is acceptable, in the case of equation 3, the value being measured does not directly relate it to co-occurrence. It only shows potential, which is why the paper is still in preprint stage. I expect that this part will likely be revised before the paper is submitted to a conference. Once we identify irreducible multidimensional features using that definition 3, we can extend the traditional linear hypothesis. In the linear hypothesis, hidden states are typically described as a linear combination of one-dimensional features and vectors. Now we can say that these hidden states result from the inner product of matrices and multidimensional features. Moreover, the process of computing the linear product between orthogonal matrices and multidimensional features can be interpreted as a projection of high-dimensional data onto a lower-dimensional space. This projection aligns with the Johnson-Linder stress lemma, which guarantees that projecting high-dimensional data into lower-dimensional still preserves the distance between points. Preserving distances means that the subspaces remain independent, which is one of the key characteristics of irreducible multidimensional features. Therefore, using the inner products of orthogonal matrices and multidimensional features provides a formal and reliable method for identifying irreducible multidimensional features. This is because the Johnson-Linder stress lemma ensures that independence is maintained during the dimensionality reduction process. Sparse autoencoder compress the input data through the encoder into the most essential features. and then the decoder reconstructs the original input using only this compressed feature. Thus, the process by which SAE identifies multidimensional features involves the following steps. First, cluster the D data into groups. Second, apply SAE encoder to the data point in each cluster retaining only the most important features. 3. Analyze the data in second process using these features and visually confirm the irreducible structures such as circular patterns that cannot be further decomposed. The process of evaluating how well the model explains the data was also interesting. First, explanatory variables are introduced. These are the variables that hypothesize how the model processed the data. We anticipate how the model calculates certain information. For example, if we ask an LLM, what day is it 2 days after Monday? We expect the model used to both the day information and the number of day passed to make this calculation, just as a human would. These pieces of information, the day of the week and how many days have passed, are the explanatory variables. Second, these explanatory variables are one-hot encoded and vectorized, then fed into a linear regression to obtain predicted value. Lastly, the residuals between the actual activation values D and predicted values are calculated. These residuals are then subjected to a PCA for visualization. That is the result. The critiques and benefits of this paper, as I see them, are as follows. I believe definition 3 needs to be revised. And since SAE primarily use linear transformations, it would be valuable to experiment with other models. The positive aspect is the process used to evaluate how well the model explains the data. I think this evaluation process is something we could apply